Okay, today I just want to do uh, a short video about ARM assembly. Um, so we're going to start. We're just going to write a short program in ARM assembly language that prints out a couple of things and gives us an idea of um, uh, how to get started with it. Because that's one thing I found really difficult, was just getting started and getting my head around the addresses. So if you're doing ARM assembly, you probably already know there's 16, um, 16 registers, 0 to 15, and they're labeled R0, R1, R2, and these registers have specific um, roles, some of them. In particular, R0 is really the one we're going to focus on today. So R0 is the main one that is dealt with when you call kind of standard, I guess you call them functions, standard instructions like software interrupts. Um, we'll get into that in a little bit. Um, so how does it look? It looks kind of like this. You have labels, you have instructions, and you have operands. Um, so you have the name here, a bit like in basic or in batch files. You you can use the labels during the program to as a reference. So you can say go to this, or you can use the labels um, a bit like variables. You can use you can define a string and you can call it by its label. Um, so we'll just dive straight into it, and hopefully by doing it, it will start to make more sense to you. So we need some instructions. First instruction is B. B is very, very simple. It means branch. It's very clever because there are some, we can use branch for conditional statements, which we'll use one um, for a loop in our first program. So basically the way you would use branch is you would have it basically jumps to another point in the file. So if I say b main, that means branch to main. So that's actually often written there, and then you'd have some instructions written here. But you could also have some other instructions and then branch back to main again. And then you have basically an infinite loop. It will do this instruction, it will jump to main, it will do this instruction, jump back to main again. And it will never get here. Um, we have define byte and define word, but for today we're just going to use them as the way we're going to use them today is that def b will define our string for printing out. Def w will define our integer for printing out. Now, bytes and words are just different lengths or different size groups of bits. So you can look that up. I'm not going to go into that now. A word is bigger than a byte, paragraph is bigger than a word, and so on and so forth. It's just programming nomenclature. We're going to use a line. A line sorts the memory for us. It basically tidies up the memory into nice 4 byte wide areas so that our program is easy to write. Basically, if I want to iterate through memory, I can iterate it by jumping 4 bytes ahead. So that's not the register, that actually tidies, makes sure that things are put into memory in nice uniform spaces. ADR, we're going to use ADR to point a register to an address in memory. So ADR is a bit like defining a pointer in C. We've also got LDR, but we're not going to use that today, so don't worry about that. LDR would be like defining a variable in C, because LDR gets the value at the pointer address. We're going to use a software interrupt. Software interrupts there are 5 main software interrupts, and we use them to do different things. We're only going to be concerned with 2, 3, and 4 today. 2 exits the program, 3 will print out the def B, and 4 will print out the def W, so print out the number for us to screen. We're going to use add, pretty self-explanatory. We're going to add something to our register or the value in our register, and then we're going to store it back to a register or the same register. CMP, compare, we use this for conditions. So a good thing about ARM is it is actually quite simple to write. This is actually how we write. Very similar to how it's going to look when we write it. So depending on the result of compare, the flags, the CPSR flags, will be a certain way, and then you can use suffixes to the branch. So B has suffixes, and these, or how do you write suffixes? Suffixes, I suppose is correct. These suffixes will branch conditionally. So we're going to use BNE, which is not equal. So if the flag not equal, I think it's a Z flag, then it will loop. If not, it will continue in the linear code. So let's write our program. We're going to start with the main. We're going to define two labeled things. We're going to start with our string, hello, def w, and then our string, def w is wrong, def b, hello geeks, because you got to be pretty geeky to write ARM code. So what I've done there, as you can see, is I've manually, in inverted commas, ended the string. So I've done a new line, or a line feed, and then a null character to end the string, and you have to do that in ARM. We're going to call this the count which is just going to start with 0. We're going to then align the memory so that it doesn't get upset, and then we're going to have our main. So ARM does 2 passes to start with. The first pass will deal with your so you don't need to worry about variables, again in inverted commas, that you're defining, because it will get them on the first pass. Then it will use the branch and it will jump straight to main and run that code. So we're going to, using ADR, as we discussed, we're going to put in the register R0 the address of the hello label. And just FYI, this is how you comment. You put semicolon. Then we use the software interrupt, and it's number 3 to print out what's in R0. So if you put something in R1, it wouldn't print that out after it using SWI3. You have to use R0 if you want to print something up to screen at this point. So if I was to just run that code, it would then print out hello geeks to the terminal, or if you have it open, and then it would be the end of the program. So here I'm going to make a loop. So we don't put the conditions at the start of the loop like in C. What we do is we have to create a go-to loop, if you like in BASIC or something like that. So I'm going to put the address of, let's check my code. Yeah, so we are going to use LDR. So after I've done that, I'm going to replace what's in R0. Instead of what's the address at hello, I'm going to put the value of count. So here is a pointer to the hello array, if you like, because it's an array of characters. Whereas, and then it prints out what's pointed to there. Here we've got the value 0. It won't be the address that count is pointed to. It will be the value 0. And then we're going to, at this point, the reason I'm typing this out, and there's a little sneak peek to what it looks like, this one I did earlier. It's very easy to get lost in this, and I want to go through it stage by stage. So we're going to print out, first thing, what's at R0. But it's a number this time, so we're going to print out the value of the number there. Then we're going to add 1 to it. So R0 plus 1. And because it's a value, it will just add 1 to that. Then we're going to compare the value. Oh, I've done that wrong. This will bring up an error. So you need to store it somewhere, and you put that at the beginning. So I'm going to store at R0, plus, the value at R0 plus 1. But the reason that I haven't explicitly said the value at R0, because you can do that, but what I've done is I've put in the register R0, which is a value of 0. Compare it to the number 4. You see, you always put a hashtag before a number. And then if it's not equal, remember this BNE, we're going to go to loop. So branch, a branch if not equal, loop. If it is equal, it will just continue. So I'm going to exit here. It's just x_2 just exits this program safely. So here's what I did earlier. I've looped it to 5, so it'll print out 1, 2, 3, 4. Let's open it up. Oh, I was playing with it before I did it. I'm using Komodo, which is Manchester University thing. It's open source, um, so by all means use download it, install it, play with it. I'm not going to do a Komodo tutorial, although maybe I will do in a later video. So I'm going to reset it and I'm going to run it. Hello there, geeks. You see I put the line feed on the end of that 1, 2, 3, 4, and then it stopped and exited the program nicely. Probably won't do that the first time, so have fun. Here's the code. My suggestion is write it out, try and understand it, write it out again, and then try and do something new with it. Look up the different loop conditions, look up CPSR, and have a bit of fun. Okay.